Assalamu alaikum. I'm Jahangir Alam. Today I am going to discuss about IAL, AS Physics, May June 2022, Unit 1, Section B, Part 2 video. Question number 11. A disk of mass M is held stationary by a force F exerted by a magnetic base as shown. So a disk and there is a magnetic base. Question number A. The free body force diagram for the disk is shown below. Downwards mg means weight, and upward F is the repulsive force, magnetic repulsive force. The two forces shown are equal in magnitude and opposite in direction. Give two reasons why these forces are not a Newton's third law pair. Newton's third law, every action has an equal and opposite reaction force. We can apply Newton's third law of motion only when two forces act on the different object and they are same type force. Here one force acts downwards, which is weight. So the forces act on the same object. Here the forces act on the same object. Number two, they are different type of force. They are different types of force. So here weight of the disk acts downwards, weight of the disk acts downwards, and a repulsive force acts on the disk, and they are same in size and acting opposite direction. So these two forces are not Newton's third law. So Newton's third law applicable when two forces act on the different object and they must be same type of force. Now question number B. The magnetic base has weight W and reacts and rests on the horizontal table. Complete the free body force diagram below for the magnetic base. So remember here a free body force diagram for magnetic base, not disk. So magnetic base has a weight, downwards weight, and there is a normal reaction force of the table, and there is also a downwards repulsive force, magnetic repulsive force. So there are total three forces. One is R is the normal reaction force. What is normal reaction force? When any object placed in a surface, then surface will give an upward force which is exactly to the weight of the object is known as normal reaction force. So here normal reaction R is the normal reaction force. So that means when this magnetic base placed on the table surface will give an upward force to the magnetic base. So magnetic base experience a normal reaction force R. And W is the weight, mg is the weight of the magnetic base, weight of the magnetic base, magnetic base, base, weight of the magnetic base, and F is the F here. F is the uh, magnetic repulsive force, magnetic repulsive force, repulsive force. So here R equal to W plus F because the object is in stationary. Okay, this is the answer overall. Okay, now question number 12. When an increasing force is applied to a steel cable, it will eventually reach its elastic limit. State what is the mean by the elastic limit. So elastic limit is the maximum force or stress up to which an elastic body behave as a perfectly elastic. So beyond this force or stress, the cable does not return to its original length when the deforming force is removed. So elastic limit, it's the force or stress. Stress. What is the meaning of stress? Stress equal to elastic force by area per unit area. So stress beyond which the cable does not return to its original length when the deforming force is removed. Deforming force or stress is removed. So it is a force or stress beyond which the elastic body does not return to its original length when the deforming force is removed. Now question number B. The elastic limit of a steel cable was reached when the force of 13.4 into 10 to the power 6 Newton was applied. The extension of the cable is 0.126 meter. Length of the cable 6 meter. Cross sectional area. Calculate the strain of the cable. It's within elastic limit. Strain. Do you know what is strain? Strain equal to change in length divided by original length. So that means extension divided by original length. So strain equal to x divided by original length. Original length is the L. How we can find out extension? If new length minus original length. But Here extension of the cable was given was 0.126 meter. So 0.126 meter, and original length is 6 meter. 6 meter. So strain will be 0.021. So strain has no unit because it is the ratio of same thing. 0.021. There is no unit. No unit. Remember, strain has no unit. Calculate the stress in the cable at its elastic limit. We know stress equal to force, elastic force divided by uh, area. Here force is maximum force is 13.4 uh, 13.4 into 10 to the power 6 Newton, and area 9.60 10 to the power minus 3 meter square. So after calculation, 1.40 10 to the power 9 Newton per meter square. So this the unit of stress. We also use Pascal. So we can use 140 10 to the power 9 Pascal. Pascal is the unit of stress. Remember, unit of stress is Pascal or Newton per meter square. On the other hand, strain has no unit because it is the ratio of same thing. Now, question number 13. A coat hook is attached to a smooth door by a screw action. So there is a screw here. Look at the diagram. There is a screw. The diagram below shows three of the forces that act on the coat hook when the coat is hanging from it. So upward vertical force from the screw, horizontal force from the screw, and downwards weight of the coat. So add a level arrow to the diagram to show the additional force required for the coat hook to be in equilibrium. So here to make it equilibrium, we need a normal reaction force. Reaction force. Why? Because the weight of the coat produces an anti-clockwise moment. On the other hand, anti-clockwise moment, and their horizontal force. So when any object is in balance or in equilibrium, then their horizontal force and vertical force both must be balanced. So there is a horizontal force from the screw, so we need a reaction force to the left direction. There is a weight of the coat and which acts downwards, so there produces a vertical force from the screw. So all forces are balanced here. Now, uh, question number B. If too many coats are hung on the coat, the hook will rotate and pull the screw out of the door. Point P is the position of the pivot as shown. The maximum horizontal force of the screw is 150 Newton and the mass of the coat is 2.6 kg. Deduce whether the person could hang more than two of these coats from the hook. So we know total clockwise moment in equilibrium yeah, total clockwise moment clockwise moment is equal to the total anti-clockwise moment. So pivot is here P point. So weight of the coat produces anti-clockwise moment. Weight of the coat produces anti-clockwise moment. So weight of the W into 0.0 pivot perpendicular distance from the pivot to weight of the coat is 0.025 meter. 0.025 meter because 2.5 centimeter we have to convert this centimeter into meter. And so weight of the coat produces anti-clockwise moment and 150 Newton. So maximum horizontal force by the screw. So screw horizontal force is 150 Newton into perpendicular distance is 0.9 centimeter. So 0.9 centimeter, we have to convert this centimeter into meter, 0.009 meter. We have to calculate weight. So 150 Newton into 0.009 meter divided by 0.025 meter. So calculated weight is 54 Newton. So total mass of the coat is M equal to W divided by G. So W 54 Newton divided by 9.81 Newton per kg. So mass is 5.50 kg. So mass of the coat is 2.6. So number of coat equal to 5.5 kg divided by mass of the each coat 2.6 kg. So 2.12. So two coats max. So now question number 14. Regenerative braking system allows an electric car to use its kinetic energy to charge a battery as the car decelerates. A car traveling at 13 meter per second decelerate to rest. The energy transferred to the car battery during the deceleration was 73.9 kilojoule. 73.9 kilojoule. Calculate the efficiency of the regenerative braking system. Mass of the car 1560 kg. We know efficiency efficiency eta equal to useful energy output, useful energy output divided by total energy input into 100%. This is the formula, base formula for calculating efficiency. So here useful energy 73.9 kilojoule, so 10 to the power 3 joule divided by total energy input. So total energy here, total energy is the kinetic energy of the car. So kinetic energy of the car is the total energy. So kinetic energy, how we can calculate kinetic energy? Kinetic energy equals to half mv squared. Here mass of the car is 1560 kg and speed of the car is 13. So 13 meter per second square. So after calculation, kinetic energy is 1.32 10 to the power 5 joule. So this is the total energy, 1.32 10 to the power 5 joule. Remember, if unit, the efficiency has no unit, so we have to convert into percentage. So after calculation, get 56%. 56% is the efficiency. So 56% is the efficiency. Now question number B. B1, drag force acts on the car as it moves through the air. State how the drag force vary with the velocity of the car. According to the Stokes theorem, F equal to 6 pi eta RV. V is the velocity. So drag force is directly proportional to velocity. So as the velocity increases, as the velocity increases, the drag force increases. The drag force increase. Now question number B2. The graph shows how the efficiency of the regenerative braking system depends upon the initial velocity of the car. For the initial velocities in the range 20 meter per second to 40 meter per second. So efficiency decreases with increasing initial velocity. Explain why the efficiency of the regenerative braking system varies as shown in the graph. So at higher speed, more work done against air resistance. So more energy dissipated. So more energy dissipated. So a smaller portion of energy is available to charge the battery, to charge the battery, to charge the battery. Hence, the efficiency of the system breaking. So, the efficiency, hence, the efficiency of the system is what?